Hi students, welcome to my channel. In this video, we are going to discuss very important and interesting concept, that is an AVL tree. What is an AVL tree? AVL tree is a height balanced. An AVL tree is a height balanced binary search tree. Now, I think you know what is meant by binary search tree. So, binary search tree is a binary tree. Binary search tree is a binary tree in which left subtree elements are less than root node and right subtree elements are greater than root node. So I have done already video on this binary search tree. If you have not seen, you please watch that video. Okay. So operations also I discussed, programs also I discussed, insertion, deletion, search operations, everything. You please go to my channel and see all those videos to understand the operations on binary search tree. Okay. So this is the next level of binary search tree. It is a height balanced binary search tree. See here, the new term you are hearing is balanced. So why should we balance a binary search tree? The tree we have to balance to overcome or to reduce the time complexity from order of n to order of log n. That means the worst case time complexity of binary search tree, insertions, deletions, search is order of n. So what is the meaning of here worst case? For example, the tree is like this: 10, 9, like a skew binary tree, 8, 7, 6, 5. For example, if the tree is like this is called as left skew binary tree. It is called as left skew binary tree. Okay. So, if the tree is like this, if you want to perform an operation insertion of 1 you want to do. So, how to perform insertion operation? So the insertion operation in binary search tree is compare 10 and 1. If it is less, move on to left subtree. 9 and 1 are compared, 1 is less, so move on to left subtree. 8 and 1 are compared, move on to left subtree as it is less. 7 and 1 are compared, 1 is less, so move on to left subtree. 6 and 1 are compared, move on to left subtree as 1 is less. So compare 5 and 1, 1 is less, so move on to left subtree. As 5's left is null, we will insert here. That means what is your observation? Your observation is, so how many number of nodes are there in this binary search tree? 6 nodes are there. You are comparing with all 6 nodes. That means the time complexity is order of n. This is the point here. So the worst case time complexity of a binary search tree is order of n. That's why to reduce this order of n time complexity to order of log n time complexity, we are going to discuss an AVL tree. So this AVL tree is called as height balanced binary search tree. Now what we are doing here? We are reducing the height in AVL tree. So that's why this is called as height balanced binary search tree, or it is called as self-balanced trees. Self-balanced trees. This is simply why should we learn this AVL tree? Reason for learning an AVL tree. This is the basic idea of learning this AVL trees. This is an important point. Okay. In the next video, we are going to discuss how to balance the binary search tree. Okay. I think you got a very clear idea of why should we learn this AVL tree. Okay, so thank you students. If you have any doubts, please send me your doubt in the comment box. If you understand this video, please share with your friends so that they can learn what is the reason of learning this one. Okay, thank you. Have a great day. If you have not subscribed, please subscribe to my channel to get the latest videos. Thank you students. Bye bye.